Hello everybody. Today we're going to learn more about piecewise functions and how to evaluate them at different values. But first we need to review some content from Math 1, specifically this thing called y equals f of x. This is what's called function notation, and we're going to see a lot of that today. So f stands for a function. It could be any letter, usually f or g. This stands for the function, and the thing in parentheses is our input value. So this is like the data that you put into your function, and then it pops out the output, which is going to be your y value. So it's just important to know the difference, whether the question is asking for the right input or the right output. So let's take a look at this first example here. We've got a piecewise function that's made of a constant and a quadratic function as well as a linear one. So let's try to figure out what this means exactly. This one's asking f of -1 is equal to blank. So that means when x is -1, since it's replacing the input here, it's asking for the output. So when x is -1, what should y be? So we just simply look over in our graph, x is -1. So in this case, y is 3. Next, f of -3, that means when x is -3, what is y? So we have -3, and it's right on the x-axis, so that is 0. Y is 0. And how about this one, where f of 2? So x is equal to 2. We want to know the y value. So here's x, but where is the function? So since there's a hole here, or an open circle, the function is actually not defined exactly where x is equal to 2. So in this case, we actually don't have an answer. When there is no function, we call that undefined. It looks like between 1 and 2, the function isn't really defined. So if I asked you what the y value is when x is 1.5, well then that would also be undefined. And lastly, when f of 7. That's not shown on this graph, but if you take a look, we have a closed dot here to end it. So it's not an arrow that just extends into infinity. It ends right here. So it looks like the function doesn't exist when x is bigger than -5 and when x is less than -5. So this one is also undefined. All right, so this is what we call a gap, where there's just a short section where there is no function. Okay, let's take a look at a different piecewise function. Call this one f of x again. So we've got a constant, a linear function, a random dot right here, and a quadratic function. So what this one is called here is actually a hole or a jump. So when you have a certain point that just happens to be, looks sort of randomly located, we'll call that a jump. So let's see how that affects our answers as we work through this. F of 0 is, well, when x is 0, what's y? It's 2. Next, f of -1 is equal to what? So when x is -1, the function is equal to +1. Now this one here is the exact opposite question. This one's saying when f of x is equal to 1, what is the x value that makes this statement true? So now this is actually my y value. When y is negative 1, what x values are present? So I'm going to look at y as negative 1, and I actually have two answers here. So x is negative 3, and x could also be, we'll estimate around 4.8. So that's like the opposite question. It happens sometimes. Now this one, f of negative 4. So when x is negative 4, what is the function equal to? So let's see, we're in this area right here. We need to know that we should include the function that has the closed circle here and ignore the one with the open circle. So this is our data point right here. The function is equal to 1 when x is negative 4. And then real quick, if I add on another question, if I want to know what f of 1 is. When x is 1, then the function is not right here. It's actually a few spaces away where y is also 1. So just watch out for any jumps or any gaps. We're just looking for which function is defined at the certain x value. All right, now let's look at the algebra form. Moving away from graphing. Here's a piecewise function written out mathematically. And remember, they each have two parts. So over to the left is our sub-functions, the small functions that get added together to make a piecewise function. And then off to the right, it lists the different domain intervals. So this tells us which function is in control depending on our domain or our x value. So let's see how we can do this. F of 3. So this is saying when x is 3, what should the function be equal to? So what you need to do is use this x value and look at the domain. So first look at the domain to decide which function is in control. Well, 3 is between 0 and 5, so therefore we're using this function. Once you've figured out which subfunction to use, you substitute in the x value, and then you've solved it. So 2 times 3 minus 3, that's 6 minus 3. So the function is equal to 3 when x is equal to 3. Next, how about f of negative 1? So I'm going to first look at my domain intervals, and negative 1 is falling under this first one. So this is our function here. Oh, that's just a constant, so there's nothing to substitute in for x. It's just negative 4. And then what about f of 0? So I'm going to take 0 and I'm going to look over here. Where does it fit? Well, let's see. It doesn't look like it fits in either one. Since this one is less than 0, this one's greater than 0, it looks like there's no function that's been defined for when x is exactly equal to 0. So, unfortunately, we have another undefined answer. Okay, now let's try a different piecewise function that has 3 different subfunctions. So f of negative 5, x is negative 5 in this case. So let's decide where we need to go. Negative 5 is less than 1, so we're using the top function. So that's just saying the function is equal to negative 5. No matter what the x value is, we just have negative 5 in this range. And now when f of 6, when x is 6, what could the function be equal to? This is all values greater than 6, and this is all values including 6, from 1 to 6. So we're going to use the middle function here, this linear function, y equals x minus 2. So I simply substitute in my 6 here. 6 minus 2 equals 4. And lastly, f of 3. Well, 3 is between 1 and 6, so I'm going to use the middle function yet again. 3 minus 2 is just 1. Okay, so now you should be able to evaluate piecewise functions either using a graph or using the mathematical notation. So just make sure you're paying attention to where the domain is and which function is in control, and you should be golden. All right, y'all. Thank you for your time.